Do you ever wonder what causes changes in weather conditions? The motions and complex interactions of air masses are responsible for many different changes to our weather systems. Think of the Earth as a big game of air hockey. The air masses are like the pucks on the table, and they're constantly moving around and interacting with each other. Just like how the pucks can have different speeds and directions, the air masses can have different temperatures and humidity levels. The air masses flow from regions of high pressure to low pressure, just like how the pucks on an air hockey table are pushed around by the air that is blowing out of the holes. When an air mass flows from a high pressure area to a low pressure area, it can cause changes in the weather. For example, when the air mass is warm and humid, it can cause it to rain, like when a puck on the air hockey table hits the edge of the table and the water inside a glass on that edge splashes out. On the other hand, when the air mass is cold and dry, it can cause it to snow, like when the puck on the air hockey table is frozen and it slides across the table. Sometimes, different air masses can collide, just like when two pucks hit each other on the air hockey table. When this happens, the weather can change suddenly, like when the warm and cold air masses collide. It can cause a storm. Weather can also be predicted within probabilistic ranges, similar to how you can predict where a puck will go on an air hockey table by looking at its speed and direction. Meteorologists use computer models and data from weather stations to predict where air masses will move and how they will interact with each other. But just like how pucks on an air hockey table can be hard to predict, weather can also be hard to predict and can change unexpectedly. In summary, the motions and complex interactions of air masses result in changes in weather conditions. The air masses flow from regions of high pressure to low pressure, causing weather at a fixed location to change over time. Sudden changes in weather can result when different air masses collide, and weather can be predicted within probabilistic ranges, similar to how you can predict where a puck will go on an air hockey table.